All right, Unit 3, Section 1. So this short little introduction to mathematical tables. The first thing says fill in the unknown values in each statement. So you should be able to do some mental math for this. So they want you to fill in 2 plus what will give you 5. So that in your head you should be able to do quickly is 3. And then 80 plus what will give you 117. So you can kind of think 8 plus 3 will give me 11, and then 0 plus 7 will give me 7. So 80 plus 37 will give me 117. And so then most of this probably is just mental math. So it says in the table shown, the mystery number was added from row 1 to get to row 2. Same thing to get to row 3. So they want to know basically what operation did you use to find your mystery number. So if I want to go from row 1 to row 2, basically to figure out what you got from row 1 to row 2, you had to use subtraction. So if I want to figure out how I got from 81 to 41, I would have to do 41 minus 18 in my head to figure that out. So I kind of had to do 5 minus 3, or I had to do 117 minus 80 in my head to get those. Okay, so it says, now use the mystery number to fill in the next row. So if I'm basically adding, so 41 minus 18, 8, 9, 10, 11, that's 3, 23. So I'm basically adding 23 every time. So I'm basically doing addition now. So what operation did you use to find the rest of the values on your table? I'm basically adding 23 every time. So I'm going to get 110, and I'm going to get 133, and I'm going to get 156. So it says to get your mystery number, so that was on the previous screen, we subtracted 2 numbers to go up the table. So when I went up the table, I basically had to, wrong way. So when I went up the table, so when I had to figure out how I got to the previous one, I went up the table, I subtracted, and then when I go down the table on these, you're adding. Okay, so now we're going to look at multiplication. So 2 times 3 will give me 6. And if I want to do 117 divided by 80, and if you stick that in the calculator, you're going to get about 1.4625, or not about, you get 1.4625. So again, you can do the first one in your head. The second one you can't. You're going to have to use the calculator to do that. So it says, what can you do when you want to know what the first number is multiplied by to get the second one? You're basically going to divide. And then, so you basically have to do division to figure out your mystery number. So if I want to figure out how I got from row 1 to row 2, I'm going to divide 54 divided by 36, and that's going to give me what my mystery number is. Okay, so now they want you to use that same mystery number to find the next row. So let me do 54 divided by 36 is going to get you, I didn't mean to move that. So 54 divided by 36 is going to get you 1.5. And so I'm going to basically multiply by 1.5. So if I keep multiplying by 1.5, I'm going to get 182.25. Then I'll get 273.375. And then I'll get 410.0625. And then, so in general, when you're multiplying by multiplication, when you're using tables with multiplication and division, you're going to divide. So when you're going up your table, when you're going backwards, you're going to divide. And when you're going down your table, you're going to multiply. Okay, so now on to the next part of Unit 3, Section 1, where we're going to identify with some linear graphs and some exponential graphs, a couple parts of the graphs. So the first parts we're going to identify are input and output variables. So we use, when relationship between two variables are shown, we use your horizontal axis. So your horizontal axis is this one. So let me draw. So your horizontal axis is this one. This is your input variable. And then your vertical one is your output. So keep that in mind. So when we want to identify our input variable, that is our number of miles traveled. So this is our number of miles traveled. And then our output variable is our number of gallons of gas used. Sorry, that was some spam. Let me turn off the ringer. Don't you just love getting spam? Okay, so that is our input and our output. Okay, so another thing that we're going to look at is as we read a graph from left to right, we're also going to describe the pattern. So as we lead from left to right, so as we look at the graph from left to right, we're always going to look at what the input does. We're going to describe what the output does. So I'm always going to say, so this is where I will want you to write a full sentence. So if I ask you what the trend of the graph is, you're basically going to tell me, as your input increases, you're going to tell me what your output does. So in this case, as my input increases, my output is also going to increase. So in this case, since I'm getting bigger, my input is increasing because I'm getting bigger. And then again, so as your input, so my input is always going to increase. So as the, and my input unit is my time. And in this case, we're always going to say increases. So as my input increases, my output unit, which is my amount in the account. So this is my amount in the account. Okay, so you'll notice that basically as this gets bigger, you're basically going to tell me what the Y is doing. So as time goes by, my amount is going to increase. And so on these, as I want you to describe the pattern, you will always write as a sentence. This is one place I am going to have you write as a sentence. So most other places I said you didn't have to worry about sentences. This is one place I will have you write as a sentence. So you tell me basically, as X gets bigger, what does Y do? Okay, so on number 3, so again, here's my input. So as my number of miles, my number of miles increases, because you're always getting bigger numbers on your x-axis. As my number of miles increases, my output here is my number of gallons of gas, my number of gallons of gas. And you'll notice that as time goes by, your gallons of gas is decreasing. Oops. Gallons of gas decreases. So it's getting smaller. All right, so now let's look at some examples of specific patterns of increase and decrease. So the following gives you populations of birds over a 4-year period. So you've got 0, 1, 2, 3, 4 years, and 20, 40, 60, 80, and 100. So they're showing you, make it an arrow. So they're showing you that on all of these, we're going to find differences. So you have to do 40, to find differences in ratios, you always do a number, and then you do either some minus or divided by the previous one. You never do 20 minus 40. You always do 40 minus 20, 60 minus 40, 80 minus 60, 100 minus 80, or 40 divided by 20, 60 divided by 40. You always want to find a difference or a ratio, because eventually we're going to figure out whether or not this is a linear function or whether it is an exponential function so that you can draw a graph. So we're going to find out a difference, meaning you added or subtracted something to get to the next number, or you multiplied by something to get to the next number. So we're going to find both. We're going to look at the differences and see if it's the same every time, or a ratio and see if it's the same. So your input values are given in the first column. And so we're starting with 0. So they want to describe how the input values are changing. And so your input values, oops, let me get a pen. We are basically adding by 1 in this case. And it's not always going to be adding by 1. Sometimes we'll add by other numbers. And then on the next one, it says the output values given in the second column, both the difference in the ratios have been calculated. Notice there is a common difference. So if you look, you're trying to look for the one that is the same or as close to the same. These ones you'll notice are not the same, so it's not a ratio. And so when I want you to fill out, it says there's a common difference, fill in the blank describing how the output values change when there is a common difference. So when there's a common difference, you talk about adding things. Rather than a ratio, you talk about multiplying things. So we're going to say the number of birds, which is this value. This is your output. You always use your, whatever the output is here. Your output item goes here first. Your output birds. And in this case, since these are getting big, oops, I'm trying to use my arrow. Since these are getting bigger, 20, 40, 60, 80, 100, you have to ask yourself, are those increasing or decreasing? They're getting bigger. So those are increasing. The number of birds increases by adding whatever our ratio is, 20 each year. And so what goes here basically is our input value. So that's why you have to know basically what your output variable is and what your input variable is. And then you have to basically know what your common difference is when you write out your sentence. Okay, on this one, they kind of did the same thing. You notice that you still have the same 0, 1, 2, 3, 4, except we've got 0, 40, 80, 160. So if I find my difference, I go from, I added 20, this time I added 40, 80, 160. So I did 40 minus 20, 80 minus 40, 160 minus 80, 320 minus 60. These are not the same, but if I divide 40 divided by 20, 80 divided by 40, 160 divided by 80, 320 divided by 160, you're taking a number divided by its previous one, or 320 minus your previous one. You'll notice that these are the same, these are not. So we're going to do basically ratios, which means you're multiplying. So again, notice that your input values start at 0, and we want to describe how your input values are changing. So basically you're multiplying by 2. And then it says both the common difference and the ratios have been calculated. Notice there's a common ratio. Fill out the output values when there's a common ratio. It says your number of rabbits. So again, your output value is here. That's what this is. And notice that, again, you're going from 20 to 40 to 80 to 60 to 320. You're getting bigger. And that's why you have a big number. If it was decreasing, you would have like a 1/2 here. So it's increasing. But instead, you're using the word multiplying instead of adding. You're increasing by 2 each year. And that is your input. So kind of the same thing as before. You have your input, your output, but this time you're using a common ratio rather than a difference. Okay, number 6. The following table gives the population of frogs over a 4-day period. Notice the input value start at 0 and increase by 1. Both the differences and the ratios have been calculated for the output values. Notice there's not a common difference, but there's an approximate ratio. So sometimes when you divide, you're not going to get exact numbers, okay? So sometimes because you've got because you're doing like population growth, the numbers may not be exactly the same, but you want to look for the one that's the closest to the same. So if I look here, my difference is 5, 6, 8, 10. And over here, my ratio is 1.25, 1.24, 1.26, 1.26. So even though this is not exactly the same, these are still closer to being the same than my differences. So I'm going to go with, I'm going to go with the differences not being correct, and I'm going to go with my ratios, and I'm going to say this is about 1.25 on average. So we need to get an approximate common ratio. So due to rounding, sometimes you have to do an approximate. So my number of frogs and is going to increase by multiplying by about 1.25. Oops, I need the point in there, each day. Okay, the following table gives you population of alligators over a 4-year period. It says, notice the input value started at 0 and increased by 1. So now they're going to make you do all the math. So make sure you remember that you're doing one number. You're going from, for example, 56 to 68. So if I do the difference, I'm doing 56 minus 58. Actually, let me make some more room. Okay, let's do over here. So I'm going to do 56 minus 58. Let's try that again. I'm going to do 56 minus 68. And then I'm going to do 44 minus 56, 32 minus 44, 20 minus 32. So that gives me my differences. And then for my ratios, I'm going to do 56 divided by 68. I'm going to do 44 divided by 56. I'm going to do 32 divided by 44. And I'm going to do 20 divided by 32. You always want to do 1 divided by the previous one. And so that's going to give me my differences of negative 12. Hold on. Let's erase this. So between here and, I need another pen. Hold on. Let me fix this again. From here to here, that's negative 12, negative 12, 12, negative 12. And then for my ratio, same thing as 0.824, 0.786, 0.727, 0.625. So you might want to take a minute and pause your screen so that you can write down all of your math. So it says calculate the differences in the ratios for your output values. We suggest you always start with the entry below and subtract or divide by the previous one. So make sure that you do that. And then use a complete sentence to describe how the output values changed. And so if you look, basically you're decreasing the alligators. And I'm going to have to do it. I don't have enough room on the bottom, so I'm going to do it on top. So the number of alligators decrease by 12 each year. Okay, the following table gives an increase in the population of guppies over a 4-month period. Notice the input values increase by 0, or start at 0 and increase by 1. Calculate the difference for the differences for the ratios and differences and the ratios. So if I find my differences and my ratios, that basically is going to be, again, if you want to do the math, you're going to do 53 minus 30, 94 minus 53, 166 minus 53, nope, sorry, not 53, minus 94, 294 minus 166, and that's going to give you 23, 41, 72, and 128. If I do my ratios, that's 53 over 30, 94 over 53, 166 over 94, and 294 over 166. And when I do that, my ratios end up 1.767, 1.774, 1.766, 1.771. Okay. So again, this is one of those ones where they don't come out exactly the same, but if you compare the two and you find the one that's the closest, this is going to be close. Oops, I need a pen. Hold on. This is going to be the one. Oh, that didn't work either. Let's try this again. Come on. This is going to be the one that's closer. You're going to use ratios. So if I, it's loud. Okay. So I'm going to say this is approximately about 1.77. And again, it's a ratio, you're multiplying. So I'm going to say that my number of guppies, my population of guppies, so the population of guppies increases. Now, the one thing you have to be careful with when it's a ratio, increases by, you have to use the word multiplying. By, multiplying. You have to have the word multiplying in there. Otherwise, I don't know it's a ratio. By multiplying by 1.77 each month. So you have to use your input. So I have to see this wording here. I have to see this wording here. And I have to have this multiplying in here to tell me it's a ratio. That has to be in there. Okay, I'm going to shrink this a little bit so I have more room to write. Okay, number 9, same thing. They give you population of bears. And so if I want to find my differences, I'm going to have, I need a pen. That works. This is going to be 3, 3, 3, 3. You can probably already tell what the answer is because these are all the same, but I'm going to do it anyway. So your 28 divided by 25 is going to give you 1.12. Your 31 divided by 28 gives you 1.107. Your 34 divided by 31 gives you 1.097. And your 37 divided by 34 gives you 1.088. Now, I know it seems like these are super, super close together. And even though they technically are, the 3's are exactly the same. So you still want to do that. So you want to use, even though if you rounded these all, they could be rounded to 1.1. You're still rounding and they're not exactly the same. So you still want to go with this one as a better pattern because it's exact. So I'm still going to go with this one. This is still not the best choice. This one is exact. So you're still going to basically want to say that your population of bears, so the population of bears increases by, and since we're getting bigger, we're going from 25 to 28, by adding 3 every year, because you're adding. All right, so same problem again. Let me make it smaller just so I have more room. So my population of tigers, if I find my differences, I'm going to have -20, -12, -7, -4. If I do my ratios, 30 divided by 50 comes out to 0.6. 18 divided by 30 comes out to be 0.6. So remember, I did 30 divided by 50, 18 divided by 30, 11 divided by 18, 7 divided by 11, 0.611, 0.636. So again, these are not exact, these are closer. I'm going to go with these ratios. So my population of tigers, so the population of tigers and in this case, their numbers are getting smaller, decreases by multiplying. And I'm going to say this is approximately 0.6. I'm multiplying by 0.6 each year. So linear patterns of change, common differences, section 1. So again, this is still the same problem. They're just reviewing this. The following table shows the relationship, miles and minutes. This is just review. So your common ratio, your difference is 10, 10, 10, 10. And then your ratio, if I did 20 divided by 10, that's 2. 30 divided by 2 is, oops, if I do them in, I'm going to do them in decimals. That gives me 1.5. 40 divided by 3 is 1.3 repeating. And then 50 divided by 40 is 1.25. It says the rate of change for the linear pattern. So, oops, I wrote it in the wrong spot. So this is linear. Basically, this is exponential. So for a linear pattern is constant. This means that your output values increase or decrease by the same amount. Determine if there's a common difference. So there's a common difference. I forgot to do it on A. So there's a common difference on A. It says the rate of change for a linear pattern is constant. So that means this is linear. That means the output values increase or decrease by the same amount for each unit increase in the input. This example shows a linear pattern of change because the number of minutes increased by adding 10 for each mile. Okay, so what if your table of values isn't given and just a description of the relationship between the two variables is given? Let's look at a new example that gives you a verbal description of the relationship between seconds and meters. So in 10 seconds, you run 106 meters, okay? So to find your average time in seconds per meter, so pay attention to how they, how they word this. It basically tells you what to do. Seconds per meter. So remember that per means division, and order matters when we write it as a fraction. So you're writing the seconds divided by your meters. So whatever word comes first, this goes on top, and then this word goes on the bottom, in the numerator and the denominator. And so this should help you determine what units in your fraction. So the seconds went on top, your meters went on bottom. So you basically had your 10 seconds. So you would think, oh, I'll put the bigger number on top and the smaller number second. But you're basically putting 10 seconds on top, 106 meters on bottom, because I want seconds per meter. And that gives you about 0.094 seconds per meter. It says, did you divide and write your answer in decimal form since you want seconds per meter? Yes. And did you include the correct units in the answer? Yes. Okay. So make sure that you pay attention to how this is worded. Basically just pretend that's a division sign and just put a division sign there and it tells you how to do it. Okay, a person descends a mountain at a rate of 1,985 meters in 6 hours. If the output decreases, we show a relationship with a negative rate of change, are the output values in meters increasing or decreasing? And so if they're talking about descending, okay, so the word descending means they're decreasing. And how do you know? So the word descends means decreasing. So should the rate be positive or negative? It should be negative. Okay. And so then your rate of change is going to be your output. So you're going down 1,985 meters in 6 hours. Okay. So that basically, if you divide that, you're going to get about negative 330, about 0.83 meters per hour. That's a bad H. Oh, okay, it's not going to let me just write a new H on top of that. There. Okay. You started, starting mileage on your odometer was 32,541. After 6 hours, the ending mileage on your odometer reads 32,863. What is the rate of change in your miles per hour? So again, they're telling you miles per hour. So you need to figure out how many miles you went. So if I need to figure out how many miles I went. So I need to figure out what 32,863 minus 32,541 is. And that will tell me how many miles I went. So if I subtract those two, I went 322 miles on my trip. So I went 322 miles on my trip in 6 hours. So that is going to give me about 53.6 miles per hour. So you just have to figure out how many miles you went and how often. That's your rate of change. All right, 5. You have the following table shows the relationship between time and distance driven in miles. Notice the table starts at 0 and increased by 2. So all the other tables we've done have gone up by 1. So this is where you have to be very careful. So if I want your rate of change, you're not only going to have to figure out how much you're going up by here, you have to pay attention to this. So this is going up by 2 each time here. And this is going up by 140 every time. Oops. Yeah. So it says, write the rate of change in miles per hour. Remember to divide so that your answer is written in miles per hour. So whenever you write rate of change, it has to be per 1 hour, per 1 day, per 1 month. It cannot be per 2 hours, per 2 whatever. So it has to be per 1. So when you do this, you're going to have to basically do 140 miles every 2 hours. So basically you're doing 70 miles per hour because it has to basically be per 1 X, whatever it is. So it has to be like per 1 hour, per 1 day, per 1 minute, etc. It can't be per to anything. It always has to be per hour, per day, per minute, per month, per whatever. Is the rate of change constant? Read the definition given in 1. And the answer is yes, because the miles increase 70 each hour. So by constant, they basically mean they're going up consistently every hour. So if I were to add in another like line for each table, I could put in a 1, I could put in a 3, I could put in a 5, and I would add in there a 70. I would add in there a 210. I would add in there whatever 280 plus 70 is. You get the idea. Okay. 6, I want to use the graph to answer the following questions. Recall that the horizontal axis represents input, the vertical is the horizontal, is the output. And 2, the rate of change is the output divided by the input. So we want to recall, and we want you to label the points 170. Ooh, I didn't mean to do that. We want to put the points 170 on here. So this point is, oh, let's not do this. Erase. Okay, so this point right here is 170. And then that one is 140. That's those dots that were right there. That one right there. That one right there. Okay. And then later on too, I think they have you do the 280 up here. So I'll just go ahead and write that in now. Okay, it says use these points to calculate your rate of change. So my rate of change, my change in my output value. So if I'm going from 140 or from 70 to 140, that's a change in 70 miles. And then 1 to 2 is just 1. That's my input value is 1. So that's 70 miles per hour. And it says looks like that. Let's look at 2 different points, and they want you to label the 1 and then the 280. And so they want the change in the output value. So going from 70 to 280, that's a difference of 280 minus 70. That's 210 miles. Oops. 10 miles. And then 4 minus 1 is 3. So you're doing 4 minus 1, 280 minus 70. So that also is going to get you 70 miles per hour. So if the vertical change on E is always the same for each unit across the horizontal axis, what do you think the graph will look like for every linear relationship? And so the graph will form a straight line. So the graph will form a straight line. Okay, I guess I should have done the box first. It says, because the graph has a constant rate of change, you can divide any change in your output by your corresponding change in your input, and it's the same. As long as you have a straight line, it doesn't matter which 2 points you pick. I can pick these 2 points, I can pick these 2 points, I can pick the second one and the fourth one, I can pick the third one and the fourth one, I can pick the third one and the first one. And no matter which 2 I pick, my slope, if you remember from your days in high school, your slope is basically going to be the same. Okay, number 7. They give you a graph and it shows you the amount of money owed and the year. So it says define your input variable. So your input variable is your, oh, I need a pen. My input variable is my, oops, let's do this again, is my year. That's this one. And then my output variable is my money owed on your loan. Okay, so it says find 2 points on your graph. It's important to find points that lie on the grid at the intersections so you can read them precisely. So I'm going to find 2 points that are the easiest to pick. So I'm going to start with this one right here because you can clearly see 2004, and that one's 35,000. And then a second point that I can see clearly is 2009 is 0. You want to pick ones that you can clearly see. So then they want you to find, it says find the vertical change and the horizontal change from the graph. So my vertical change, I went from 35,000 down to 0. So I went down $35,000. That was my output. And then I went from 2004 to 2005. So that's up 5 years. So then my rate of change is going to be minus 35,000 divided by 5. So I'm basically going down $7,000 per year. So it says interpret your rate of change. So when I want to interpret the rate of change, I'm going to write this as a sentence. Basically, the amount owned, or not owned, I can't even read my own handwriting. The amount owed, owed on the car decreases by $7,000 per year. Okay, so 8 wants to find and interpret the rate of change. So this is my number of cell phones and the cost of accessing my shareable data. So on this one, basically my rate of change, so I had, if I look at, I need a pen. So this was at 150. I'm going to say this was at 270. So I'm just basically going to go 70 minus my 50 over my 2 minus my 1. So 20 over 1 is 20. So basically my cost, so the cost of accessing shareable data increases, because this is getting bigger, increases $20 per phone because you're going up. Okay. The number of cookies in a jar decreases by 6 every 2 days. So find and interpret the rate of change. So again, remember everything has to be per day, not per 2 days. So if it decreases, so it decreases 6 cookies every 2 days. So that's basically 3 cookies every 1 day. So my number of cookies, so the number of cookies decreases by 3 cookies every day. So everything has to be per day, per 1 day, not per 2 days. So that one just needs to be reduced. Basically, think of it like reducing fractions. So it has to be basically per 1 day, 3 and 1 instead of 6 and 2. Okay, so in 2007, tuition was $67 per credit hour. In 2013, it was $106. Assume the rate of change is linear. Complete the table below. So it was $67 here. And in 2008, in 2013, it was 106. So assume the rate of change was linear. So if I do 106 minus 67, and then 2013 minus 2007, that is $39 over a course of 6 years. That's $6.50 per year. Okay, so if I do $6.50 per year, that means in 2008, 67 plus 650 will give me $73.50. And then in 2009 plus 650, so if I add another 650, will give me $80. But what you have to be careful with is they're missing the years 2010, 2011 in here before you get to 2012. So if I take the 80 and add another 650, that gets me $86.50 for the year 2010, plus another $650 for the year 2011. That gets me $93 for 2011, plus another $650. That will now get me to my $99.50 for 2012. And then if I add 650, I should get to my 106. So that's where you have to be careful. It's missing my 2010 and 2011 from the chart. Okay, so this is you've got to find your rate of change first from these 2 years, from this one and this one. That's a bad start, before you fill out the rest of the chart. All right. 11, match the description to the most appropriate graph below. So the first one, my dog always runs out the door, runs as fast as she can. So that's one motion, and then stops in the middle of the yard. So basically they're not gaining any more distance for a couple seconds to tell everyone she's out, and then she trots to the fence. So for this middle one, where she stops in the middle of the yard here, you basically need a flat surface right here. So that's D. So that one's done. This next one, a puppy trots out the door, sees a squirrel and stops, then creeps on her belly for a second, and then sprints as fast as she can to see the squirrel. So that one has 4 parts to it. So she stops, but not for long. So she stops right here is where she stops, and she creeps. So she's going kind of slow right here, and then she sprints real fast. So that's A. My Chihuahua walks very slowly out the door into the yard and makes sure she stays out of the big dog's way. Then she runs a little and then sprints for the fence. Of course, she's barking the entire time. So at the beginning, her Chihuahua walks very slow. So if her Chihuahua walks very slow, that means they're not going at a fast pace. So they're not gaining much distance. So that's going to be B. And so all that's left is C. So the Great Dane runs to her favorite place in the middle of the yard and then lays down. So here's the laying down part. So here's the part where she runs. So that's C. And then the last part says, when comparing two positive rates of change, the graph with the greater rate of change is blank than the graph with the smaller rate of change. And so if you've got a positive rate of change, meaning your slope, so if I've got this one with a rate of change, say, of like 3 versus a rate of change of 2, so here's one with 2, okay, it's going to be steeper. So I should say more steep instead of steeper. It's going to be more steep than the graph with a smaller rate of change.